Here we go, everybody. This is going to be your very first lesson from all of calculus, AB. Now, we're going to study limits. The first chapter is all about limits. Basically, calculus exists because of limits. The derivatives and integrals we're going to do are all based on the existence of limits, the use of limits to prove everything else. So we are going to build a foundation of what is a limit. So I'm going to give you a couple of not official definitions and kind of give you an understanding of what's going on here. So let me draw a picture of a graph so we can get started here. And I'm going to draw some random function. And we'll call that function f of x. And we'll pick an x coordinate. We'll call this A. And we'll pick a y coordinate. We'll call that L. And for a future problem, so let me go ahead and draw another one. For future. And this one's going to be a constant function. And I will label a couple points again. That's A on the x-axis. And on the y-axis, we'll call that point there L. All right, so what is a limit? And here's what happens. There's a lot of misconceptions people have about limits, and it will confuse you and make you miss easy problems. So make sure that you're absorbing all the things I'm saying and they make sense to you. So, let's see. That's not the color I want. I want blue. More like that. Okay. I like that. So suppose a function f. When I say function f, what does that represent on the graph? You have to realize when I say function f, that represents the y values. A function gives you y values. So it says, suppose the function f defined for all x near a. What does that mean? Defined for x near a. So what is that saying? I should do a different color there because you have to see what's going on. It's defined for all x near a. What does that mean? Near a. So these are the x values near a. But it doesn't have to exist at a. So the function doesn't have to exist, but I'm going to highlight here. These are values of x near a on the function. So x is a horizontal, the y's are the vertical axis. So the function must exist near a, but not necessarily at a. Let's keep reading this. F of x is arbitrarily, what does that mean? Arbitrarily close to L. I have in parentheses, as close to L as we like. So this black function here, we can get it to be as close as we want to L, whatever that y value is, for all x really close to a. So if you pick values of x, really didn't want to use that, values of x super close to a in that interval, then we can guarantee that the y value, yeah, I probably should do that. So I'm going to erase that. If I can get the x values really close to a, even closer than that, then I guarantee the y values are between those y values. And this arbitrarily close that we see here, basically saying, if you want me to get closer to L here, if I shrink this down, all I have to do is shrink down the x. So as close as you want me to get to L, I can get you that close if I narrow down my x values. That's kind of confusing. And I want to point out one more thing. X gets sufficiently close to A. It never reaches A. In the limit, I never get to A on the x-axis. If you get confused with that, you will miss a lot of problems and it's going to confuse you. So I just want to emphasize that. You do not ever reach A. So what does this problem say? Limit. That means as I approach A from both sides, as I approach A from both sides, and this is saying x approaches A. Keyword approaches, it never reaches A. Let that stick in your brain. So as I get closer and closer to A from both sides, f of x, this represents the y values of f, the function f, the y values. So the limit saying, what does the y values approach? What do they get really close to? And in this, it's saying they get really, really close to L. So the y values approach L, or could actually equal L. And let me show you over here. As I approach A from both sides, you can see that as I get closer from both sides, not only does a function approach L, from either side, the value of the function is L. So the limit can equal the y value of the function, but the x approaching A here, x can never reach A. So my second definition, which might help you understand, f of x, or the y value of the function, gets really, really close to what? It gets close to L, as x gets really, really, really close to A. And again, I emphasize really, really close to A. It never reaches A. It just gets close to it. But the y value could or might not equal L. So with this definition, this function gets really, really close to what? It gets close to L as x gets really, really close to A as I approach x from both sides. So make sure that's sinking in. Make sure you are distinguishing the difference between x approaching A and the y value approaching L. X is moving in left and right. Approaching L, I'm getting closer and closer to L or equal to L on the y value. So I'm going to emphasize a few things because these are very important, and I've said it a lot already. X approaches A, x never reaches A. Very important for you to know. I do not ever reach A in a limit. If you think it reaches there, it will confuse you to no end. X never gets to A. And since the limit x never gets to A, the limit does not tell you what happens at A. And what happens at A doesn't necessarily tell you what the limit is. And we'll see some examples of that. The function doesn't have to exist at x equals A for the limit to exist. Same idea. If the function, I'll look at this previous one, suppose at this point, there's actually a hole. The limit would still exist because I don't care what happens at A. I only care what happens around A. So the function doesn't have to exist at x equals A for the limit to exist. Okay, and then I need to add a caret equal. The function might or might not equal L. Okay, if you look in this case, as I get closer and closer to A, the function never equals L. It gets really close. In this case here, though, as I approach from left and right, the function equals L from both sides. So the y value can equal the limit, but the x value never reaches what you're approaching. So that's what I want to point out to you. And we're going to do some examples here. So I'm going to do one example for you, then you will pause this video, and then you will watch the other, or you will try the other three, and then I will give you the solutions to see how you did on that. So the first one, we want the limit as x approaches 1. So here's 1, and I want to approach that from both sides and see what happens. So here is close to 1 from both sides, and I'm going to approach on my function 1 from both sides. So the question's asking me, what does f of x get really close to? F of x is, whoa, that's not what I wanted. F of x is the y value. So as I look here, as x gets close to 2 or 1 from the left side and right side, what is the y value getting close to? And hopefully you can see it's getting close to 2. So that answer is going to be 2. Now remember, in the limit, x never got to 1. It just got really close to 1. But here, they want to know what the value of the function is at 1. So at 1, at this point, clearly the function equals 2. So this case, the limit does equal the value of the function at the point. So go ahead and pause this video, try 2, 3, and 4, and see how you do. And I'm just going to continue on because I'm assuming you're pausing, and then when you replay, you'll hear what I'm saying. So we're going to look at the next limit. And in the next one, I will do this in orange. Ooh, I don't have an orange here. I have to pick an orange. That looks like orange. Okay. So in this case, x is approaching 2. So there's 2. There's my region right there. And so I'm getting close to 2 from both sides here. But what does that look like of f of x? F of x would be right here. So as I approach 2, I never reach 2. But on the graph at this point, as I approach from each side, the y value here equals 4. The y value here approaches 4. Since they both approach 4, this limit will be 4. Now, what's happening at 2 itself? Let's take a look-see at 2. So 2 is right there. The y value, if you look at that point there, it's an empty hole. It does not exist. So therefore, f of 2 does not exist. And we write it with D and E. That represents does not exist. So that's what's happening at 2. So you hopefully have already done 4. If not, pause this, and then you can resume. So at 4, it's going to be this region. And I'm approaching 4 from both sides. And as you can see, as x gets close to 4 from the left, the y value not only gets close to is 4. As I approach 4 from the right, the y value gets really close to 4. So clearly that is 4. And what's the y value at 4? If you look, there's a big dot there. That means it equals 4. And off to the last one, 7. We'll do Poiple. I gotta choose Poiple from this list. That looks pretty close. All right, so we're approaching 7. Around 7 will be there. So it's that region and that region. So we're approaching 7 from both sides. But what are the actual y values? There's the y value. I am in a dilemma right now, because as I get close to 7 from the right side, the y value is getting close to 4. But as I approach 7 from the left side, the y value gets close to 6. That's a problem. You don't know this yet, but it's not getting close to a single number. To have a limit, you must be approaching a single number. And since the left and right approach different numbers, we say that this limit does not exist. Okay? Hopefully that makes sense to you, because we have to get really, really, really close to a number. If I asked you, as I approach 7, what do I really get really, really, really close to? You can't say 4, because from the left, I don't get really, really close to 4. And you can't say 1, because from the right, I don't get really, really close to 1. So therefore, I don't approach any number, so I don't have a limit. But at 7, the graph exists at 6. So f of 7, I would say, is 6. Hopefully you did well on that. If you were confused on any of those, you can ask me questions tomorrow. Okay? Let me go on to the next topic, one-sided limits. This is hopefully not too hard of a concept. Basically, you are only approaching from one side or the other. So let me explain here. That little negative sign there says approaching from the left. So approaching from the left. That means you're coming in this way. And the little plus sign here, the exponent's a plus. That means you are approaching from the right. All right, that means you're coming in from that side. So everything else is pretty much the same as before, but now you're only coming in from one side. You don't have to look at both sides. And I want to put a box, a red box, and I want it hollow. Where is the inside? I don't see additional settings. I want nothing on the inside. Uh-oh. How do I get rid of and make hollow? I don't know. Okay, I don't think it's going to happen the way I want it to. Let me experiment. Oh, that's okay. It works. Oh, I see what's happening. I want 100%. Let's try this again. Oh, but I want to make it hollow. Properties, border thickness, full color. How do I choose nothing? I don't know what that is. Let's see. Sorry guys, I'm kind of experimenting with you guys. Yeah, that's going to cover it. Okay, I give up on that. I'll just box it by hand. Here's a theorem. Whoa. Assume f is defined for all x near a except possibly x equals a. So same idea, the function needs to exist around. Then, this limit that we just studied, if that limit exists and equals L, then it must be true that the limit from the left and the limit from the right both must equal L. So that should make sense. So one more time, for this limit to exist, as I approach from the left and I approach from the right, they both must be L. So if I say this, I'm implying left and right equal each other. And in the if and only if statement, we can go backwards. If the limit from the left is L and the limit from the right is L, we can assume the limit is L. So there's a connection. If this is true, then these two must be true, and vice versa. So, oh no. Oh well. My screen number 4, 4B, and 4C got scrunched down below. So I will do number 1 for you. Then there should be a pause, and you should do 2, 3, and 4 the same way. So number 1, do I have 1A, 1B, 1C? Yes, I do. Okay. 1A, let's do it in, I guess purple is going to be our color. Nah, I want to do red. I like red. So I'm approaching 1 from the left. What does that look like? That's this side here, or this side. So as I approach 1 from the left, so the idea is here, an x value approach, but you want to know what the y value is doing. So to find out the y value, I need to go on my graph. The y value as I move from the left clearly is 2. So I'm going to put a 2 there, I think. Bam. Now I'm going to do this one. I'm approaching 1 from the right. I should do a different color. Yoshida, you're going to confuse the students. Green. Okay. I'm approaching 1 from the right. So that means I'm on the right side or over here. So I approach from the right, but to see what the y value gets close to, I need to be on the graph. And clearly, as I get closer and closer to 1 from the right, the y value gets close to 2. So that is a 2. But then it asks us this third question. My, why didn't it have a dark blue for me? Dark blue, okay. What's the limit as x approaches 1? Now, we shouldn't have to look at the graph anymore. We have this theorem above. If the limit from the left is L and the limit from the right is L, then the limit's L. Since the left is 2 and the right is 2, quickly, I just write a 2 there. Okay? So try number 2 and 3 and 4. And I will go ahead and pause, and I'll come back and do these for you. Okay, I'm going to start going a little bit faster. Hopefully you guys are starting to get the hang of this. If I'm going too fast, again, just pause the video or rewind it and you can hear again. Let me start with red again. The red will always be from the right for us. Or, no, it's from the left, sorry. So we're approaching 2 from the left. Well, here's 2. And here's to the left. So I want to approach from the left, but I need to know what the y value is doing, so I have to look at the graph. And clearly, as I get close to 2 from the left, the y value looks like it's getting really close to 4. Hopefully you got that. Then we're going to approach from the right. So I will pick green for that. So we're going to approach on this side, the right side of the function. And I want x to approach 2, but we want to know what the y value is doing. So we have to go to the graph to see the y value. And clearly, that is 4 also. And so the last question will be, what's the limit as x approaches 2? I don't have to look at the graph. If the limit from the left and right are both 4, then the actual limit shall be 4. Whoa, bad. All right, number 3. Hopefully you've done that. If not, pause. Right, we're approaching 4 from the left. Well, 4 from the left is this side. And we're going to approach, the x approaches 4, but to see what the y value does, we need to look at the graph, which is there. So clearly, as x gets close to 4 from the left, the y value is 4. We will go to green. Now I'm going to approach 4 from the right. All right, from the right of 4 is this side. And once again, I need to see what the value of x does on that, y value, sorry, on that side. So I have to see what does the y value get close to. And as I approach, the y value is close to 4. So again, the limit from the left and right both equal 4. Therefore, at 4, that is the limit 4. All right, number 4, it's kind of hidden if you haven't done it yet. It got down here, it got scrunched for some reason. I'm sad, but I can't redo this whole video. We're approaching 7 from the left. So 7 from the left, we're looking at this side, which on the graph is here. So as x approaches 7, the y value, we need to look at the graph, and it looks like the y value approaches 1. So I'm going to do a 1 there. Now I need to approach from the right. So approaching 7 from the right, to the right of 7's over here. On the graph, to the right of 7's over here. And let's take a look-see. So I'm approaching 7 from the right on the x, but to see the y value, it's over here. And as I approach 7 from this side, the y value gets close to 4. So that limit will be 4. Oh, I just realized I messed up. You guys are probably screaming at me. Woo! Bad, Yoshida, bad. This was 2. Whoa! Bad again. 2. Okay, so the last one that's kind of munched up in there is x approaches 7. You don't have to look at the graph. The limit from the left is 1. The limit from the right is 4. But since these two don't equal each other, then this limit doesn't exist. These two must be true for this limit to exist. So we say this limit, wow, Yoshida, wow, does not exist. That is your introduction to limits. We'll be spending more time on limits. That's just the start. You will have an assignment that I will post, but hopefully you get that. If not, you can ask me questions tomorrow in class. We'll do more of these, and maybe I might introduce to you new limit concepts. So be ready to ask questions, be ready to clarify, and hopefully this was easy. If not, don't give up. Just keep processing and ask questions till it makes sense. Have a great rest of your evening. Bye.